Okay, good evening, everyone, and let's welcome all of you to CAWASA Webinar of the 2022 series number 7. And we have some special guests with us this afternoon from Sentry, and they're going to speak about remote technical and water quality support for operators of water and wastewater treatment assets. They say that the operation of water and wastewater treatment systems is challenging for even the most experienced operators. These operators are typically required to operate this infrastructure with very limited technical support and limited available information on water quality, both entering and leaving the treatment facility. The Sentry team provide a remote technical support and water quality platform for operators of water and wastewater treatment systems. Sentry provides its clients biofilm-based sensors that monitor the performance of treatment infrastructure in real time. The probes are designed to be in difficult conditions, which means they can provide low maintenance and reliable information and the influent and effluent of wastewater treatment plants. Though working with over 130 deployments globally, Sentry has developed standard operating procedures around the use of the signal. It is being used to help protect vital biological treatment processes and optimize them for energy consumption. This evening we are joined, I think Patrick Kelly is the CEO, but we have with us this evening Alex Webb and Tim Truax, and I will now invite them to introduce themselves to the team. Thank you and welcome.
Thank you, Ignatius.
All right.
Alex.
Thanks. Yeah, so I'm the rep manager for Sentry. So what that means is I basically work to help get our product out to individual wastewater treatment facilities using technical reps who have relationships with the facilities and can provide on the ground support and any troubleshooting, things like that. Because as Ignatius mentioned, this is a remote technology. And so we're offering analysis support and data interpretation support, but it's designed to be very simple so that it can be implemented without necessarily needing that additional technical on the ground support. But we like to have someone nearby in case that they do need any help. Again, as I mentioned, I'm based out of eastern part of Canada, Montreal. And I guess broadly, my background is in industrial sales, political science, and I have a master's in water resource management. So looking at water more holistically as a resource, and I'll pass it over to Tim.
Thanks. My name is Tim Truax. I have been with Sentry since May last year. I was a Sentry client when I was managing the Bend, Oregon wastewater treatment facility. I am located on the eastern slopes of the Cascade Mountains in Oregon in the United States. I've been a manager and operator of wastewater treatment facilities for 40 years and am now moving into a support role as a client manager for Sentry to help derive value from the Sentry signal and our platform.
All right. So we'll get started on the technical side of things, unless you wanted to.
Well, you can proceed as you wish. We also have the opportunity to, you can access the screen share if you wish to share any slides. And
yeah, didn't work. There we go. Hopefully that worked.
Looking good.
Excellent. There we go. Oh, we're getting some feedback from somebody, I think.
That means that somebody's logged in twice.
Okay, better? Better. All right, good stuff. Right. So the way we'll do this this evening is that I'll give a fairly high level technical overview of how the sensor works and what the technology is. But really that we'd like the focus to be on how you could use it in terms of operators in making decisions and what that additional data means in how you do your day-to-day. So that's where Tim will talk a little bit about how he was able to use the sensor, where he was able to put it in the facility and what information that gave, and then the operational changes that he was able to make being able with that additional data. So as we get started, I always like to start our presentations with saying that at Sentry, we care about the environment, and we're focused on facilitating better water and wastewater treatment decisions for better environmental outcomes. And we do that through offering this additional data. It seems simple enough as a mission, but as all of you know, as operators, there's a lot of factors and challenges which make wastewater treatment not the easiest task. You have your incoming influent, which is changing. You have upstream dischargers who are discharging things at any time, not necessarily telling you what's in the wastewater or when it's going to arrive. And that's well out of the operator control. You're also working with a live biological process, which means there is variability in how the biology is going to react when the water arrives at the facility. Traditional sensors are not really built to withstand a wastewater environment, and they have to be cleaned regularly to be able to provide early warning data. So they're typically put much further down in the facility. Or you're relying heavily on costly and labor-intensive manual sampling, which only gives kind of a snapshot of the water quality data, and it often only gives it hours or even days later when you're talking about a BOD5. So all of those things together make it a big challenge to be able to really dial in your wastewater treatment with consistency and with those outcomes that you're looking for. So we're going to talk about the Sentry in the context of being able to do different things based on what your objectives are when you're trying to improve your treatment process. So that can be looking at a biological imbalance. So that's things coming into the facility that you're not expecting or that damage the treatment biology. That could be using the equipment you have more effectively, or if you're doing any anaerobic digestion, it can be applied in that sense as well. We also do work in the raw water and drinking water side, and we can certainly talk about those experiences if there's interest as well. So now I'll talk a little bit about the technology itself and how it works, which is really what makes it unique to other sensors that exist. So the Sentry sensor is a low maintenance biofilm sensor. It consists of a control panel and up to 4 of these probes. The system was designed to be in a wastewater environment, so that means it's robust and it's easy to install. And the way that it works with the wastewater is that it actually uses the biofilm that grows on all the sensors, which you'd typically be trying to clean off because it's interrupting the signal. What happens is as that biofilm is growing, our sensor is actually an electrical circuit. So as the biofilm is consuming the organic matter in the wastewater and breaking those chemical bonds for energy, that energy is captured by the circuit, and we are able to count that as electricity. So we're essentially able to measure the ability of the biology to process or treat the wastewater. So another way to look at it is like a heart rate monitor for the biofilm, where we're really looking at how much is the biofilm eating and how healthy is it to be eating organic matter. How this works remotely is that the sensor and the panel work in conjunction, where the sensor sends the data to the panel, which is equipped with a SIM card, and that sends that digital data to a dashboard, which is hosted in the cloud. So that means that anywhere on any internet connection, you can log in and be looking at that data. And the data is minute by minute. So what that means is that we're able to be, even remotely as a support team, watching that data happen in real time and start to react when things go out of the normal range. So if the line goes up, there's likely been a large organic load that's coming into the facility, like brewery waste. But if the line goes down, there may be less activity due to an influent event like a heavy rain, or if it's a really sharp drop that's unexpected, it could be something like a toxic chemical. And the panel could actually also be integrated directly into an in-plant monitoring system like a SCADA, so that the operators can be watching the Sentry data in conjunction with other parameters that they're measuring to be able to contextualize what's happening with the biofilm with other parameters, and then start to choose their course of action based on several points of data instead of just one manual sample. So we've identified several problem statements in the wastewater process that are based around the Sentry probe. And there's two reasons for the versatility of the sensor. One is that we can go where other sensors can't or don't function very well. So that's places like the primary clarifier or the collection system. And the other thing is that there are biological processes that take part throughout the system. And so being able to monitor how the biology reacts is useful at other places in the facility. So typically our clients would start with a sensor in the primary clarifier, and that's to get a profile or a fingerprint of what comes into the facility and when, but with an early enough warning to be able to act on what's happening. Then they can do one of two things as the pilot or the project progresses. So they'll often move further upstream if there's a specific discharger that they're of concern. So as mentioned, breweries or other food and beverage production or industrial dischargers that are of concern. And so they can start to pinpoint exactly who is discharging what and when, and then increase that lead time. The other way to utilize the technology effectively would be to move it further into the process and start to optimize around a specific part of the treatment train. So that might be aeration optimization or carbon or chemical dosing, so additives, things like that. And that way, the operators are able to start to make decisions based on the things that already cue decision making, such as smell or gut feel or other parameters, but they can also have a real indication of how the biology is reacting, how their treatment is affecting the level of organic load in the water. So a little bit more information about the system itself, more tangibly. So we have the panel, which can be installed outside. A lot of wastewater treatment facilities are, mostly external. So the panel is installed, and that's where we have the connectivity. It's kind of like the brains. And then the sensor itself can be installed in a channel, which is a really effective place for having the right amount of flow into a tank, like an EQ tank, or into an inline, like a recirculation line. And so these different ways of installing allow a little bit more flexibility based on, no two treatment plants are really alike. So as we're trying to figure out exactly where the best place is to get the data that you're looking for, we're able to install it in a variety of locations at the facility. The goal is that it's a low maintenance sensor. So that's as it uses the biofilm, we want that biofilm to grow on the sensor. And so we recommend at most monthly or quarterly inspections. And if it does need to be cleaned, then a rinse is usually adequate to dislodge any large debris. And the goal is that biofilm that we're seeing on these two sensors here, that's really what's driving the beautiful data that we can see in the graph, where both sensors are tracking very well together, showing the ups and downs of that organic loading, showing that that biofilm is very stable. And that's despite having been installed well over a year apart and without having had any maintenance. Now, not all installations are quite this dreamy, but the goal is that having it installed in those harsher environments, we're still getting really strong, very useful data out of the sensor. So as Ignatius mentioned in the intro, we're now well over 130 installations globally, and that's in systems ranging from classic wastewater treatment, anaerobic digestion, heavy industry, and all the way to raw water intake monitoring, and even monitoring in the distribution system from drinking water facilities. So I'll jump forward a little bit and just sort of talk again about the idea or the real value of having this real-time, ongoing, and biology-based monitoring is that what it's doing is it's giving a good indication of, sure, yes, organic loading, but I mean, COD and BOD do that. It's just that those are usually only 1 or 2 samples throughout the day at most, or you're looking at a composite. So you're not necessarily knowing what's coming in exactly when it came to be able to make those adjustments on time. Or you're looking at a DO sensor or an ammonia probe sort of towards the end of the treatment train. So if you flag something that's out of range, there's not really a lot you can do to act on the water that's going by the sensor. It's kind of already gone past. So having that upfront bio-based detection tells you, how will this water impact my treatment biology? Is it going to like it and be really, really active? Or is it going to, cause a die-off? So I need to be a little bit more vigilant about adding any supplemental carbon, or maybe doing a bypass, something, whatever is in your capacity at the facility to be able to manage that. But it tells you when you need to know and not after. And then the additional part is having such a large data set with 1,400 data points per day. Now the patterning and the statistical analysis around what comes in on a Monday morning versus a Thursday afternoon can start to pick out the trends throughout the week to be able to do preemptive planning, to do maintenance on lower load days, or to recognize that Mondays are going to be a tough one, whatever it is that you start to see in the data. And it can also help diagnose specific issues that may be reoccurring, to be able to better identify them as they start. So I will pass it over to Tim to talk about his experience at Bend. And while I do that, I'm going to pull up our statement of, our standard operating procedure. If I can find the right file here. Sorry, 1 second. There we go. Just as a little bit of background on how the Sentry signal can be used to trigger some of the actions that would normally take place, or even increase your capacity to act as an operator. Tim, I'm not sure if you have did you want me to pull up the Bend slides, or did you want to just talk to them?
Are the slides are the case studies in your presentation?
Let me double check and I will let you know. I don't think I have Bend. I can pull it up though.
That's okay. You could go back to the
oh wait,
first.
Yes, I do. It's here.
You do.
Yes.
Okay.
Okay. Good job.
That's great. That's great. So Bend, Oregon is, as I say, it's on the eastern slopes of the Cascade Mountains. It's a very arid climate. This is an aerial view of the treatment facility. It has a fine screening off on the very far right, a splitter structure that goes to 3 primary clarifiers, and then the primary effluent flows to one of 4 aeration tanks. These tanks are configured as a 4-stage Barden-Foe process. Because the effluent from this facility is discharged into infiltration evaporation ponds, the regulatory agency wanted to make sure that the nitrates present in the effluent from the facility would not impact drinking water for the down gradient users of that groundwater. This facility is situated in a very popular tourist location. The mountains are close by, so skiing, fishing, water sports generally, hiking are all very important parts of the local economy, as is the 26 breweries that happen to be located in Bend. This facility has approximately 24 breweries connected to it of various sizes. Some are 100 barrel or 100 gallon fermenters up to 12,000 gallon fermenters. The municipal population is about 90,000. The population equivalent, however, is more than double that. And that's because of the high strength waste associated with these breweries. As a result, I faced some challenges managing a plant with extreme swings in the organic loading coming into the facility, coupled with the COVID pandemic and the lack of human resources in the laboratory. I felt like I was flying blind a lot of the time. Now, this sensor was installed in the primary effluent of one of the 3 primary clarifiers to give me an indication of the amount of organic matter that was going to go over to the activated sludge system. The facility has a lot of problems associated with poor settleability associated with a zooglio biomass, a slimy kind of biomass that would not settle very rapidly. So I was forced to operate at very low solids retention times, so low that it became difficult to do nitrification and denitrification to get to our total nitrogen limitation. After installing the sensor, shortly after installing the sensor, I saw this signal from the clarifier, from the splitter box, and the subsequent conversations with the brewery, the largest brewery in town, indicated that they had discharged some bad beer, which was unsellable shortly after the pandemic started. This information was not captured in any BOD or COD analysis because of the labor constraints that we had, but we saw the load coming into the plant and made adjustments to the plant processes as a result. So as a result of seeing the organic loading increasing, there were a number of things that I, as a manager, could do to manage the processes of the plant to try and mitigate the effects of this slug load, which is coming in. One thing was to change the internal mixed liquor recycle rate to return more nitrates to the head of the anoxic zones at the front of the aeration tanks, with the idea that the oxygen molecule on that nitrate, the oxygen atom on the nitrate molecule would be used for BOD respiration. It also gave me the ability to know when I could increase or decrease the DO set point in our return or in our aeration tanks, as a result, saving some electricity during that process. It also allowed me to look at the pattern of organic loading into the plant, and because I had some control of the ability to return high concentration centrates from our dewatering processes, I could look at times of the day when the organic loading coming into the plant was low and return that high centrate concentration during that time of the day.
All right. Well, I think I meant to pause and ask for questions between the technical part and the case study part, but we powered right through, so that's on me. So does anyone have any questions about the sensor technology, how it works, where it might get installed, and kind of what's telling us, or about the Bend case, about how Tim was, like, where he put it, and what his findings were beyond the case that we've laid out?
Alex, do you have any other examples of places that are more like the Caribbean in terms of temperature and things like that?
We do. So I'm not sure about the humidity necessarily, but we do have several installations in California. There's actually quite a bit of variability in what. So the way we usually operate is we as we're deciding, where should we put the Sentry, what data are you trying to capture? What we do is we identify a problem statement. So in Tim's case, his problem statement was the variable loading brewery discharges. And in California, we have different problem statements that address different concerns from facilities that either have industrial dischargers, food and beverage. Maybe they have mystery toxic influent, or in Alberta, highly variable climate where you're having to do shutdowns because of power constraints. So I guess to answer the question more, it's less about the climate that changes the installation. It's really more about the type of facility and then the problem statement that we're trying to address. That really kind of that's how we sort our cases. So I guess my return question to that, because the sensors are sensitive to temperature, but we have sensors in pulp and paper effluent, which it goes up to about 50 C in the effluent. So in terms of high temperature or low temperature, the biology will be as reactive as the biology in the treatment process. And so again, that's why it's such a great measurement, is it's not just telling you abstractly that your measurement is 4. What it's telling you is that your biofilm in your facility is going to react poorly to the water that's coming in right now. And whether that is because there's something toxic, or there's not enough biomass, or there's not enough organic loading, so it's starving, or if it's because the load is much too great and it can't keep up and it can't grow fast enough, at least you're able to tell exactly how your specific biofilm at your specific facility is going to be reacting versus any other facility.
Yeah, just building on what Alex says there, our sensors have been installed in locations where the influent wastewater temperature is less than 10 C and up to 50 C. We got our start in anaerobic digesters where we're trying to keep 35 C temperature most installations. So the temperature is not as important as Alex says, as the location and the problem that you're looking to address with the sensors.
So I guess maybe to build on that, Valerie, is there anyone in the audience or yourself who, are there specific problem statements that you are curious if the sensor could address it? And then maybe we can talk about a case where we're working on that.
I'll let some of my colleagues who are technical ask.
Sure. And I mean, if someone wants to jump in, I know that's a bit of an abstract question. So I guess, to give you some ideas, some of our problem statements fall under, for example, trying to optimize aeration, where they're typically either over aerating or under aerating, and it's hard to get a good handle on the exact aeration or DO set points because the influent varies greatly. So sometimes it's very low and sometimes it's very high.
Another example of optimization might be in a trickling filter, where you have the ability to change the recycle rate and you are looking at optimizing the amount of BOD that's removed in your facility. If you know the amount of BOD entering via the Sentry sensor, then you could increase the recirculation rate through the trickling filter to try and remove more BOD before it goes on to the secondary clarification process. That's another example of where we would see applicability in warmer climates for sure.
Nitrification and denitrification are other applications where we can help optimize the loading ratios. And then I'm not sure how many are on the drinking water side, but I can also walk through a case on either freshwater influent monitoring, source water monitoring, like watershed management, and or distribution, like chlorinated drinking water distribution. So I'm not sure if any of those resonate with anyone.
Speak up, guys. Glad to see something on the water side.
Well, I mean, I can definitely do a water side one, and then maybe that if people, as I mentioned, if you want to type your question in the chat, if you're not comfortable speaking out into the group, or you have any audio challenges, technology, but no, like feel free to get as technical as you'd like or as high level. Like really, we totally recognize that this is a bit of an unusual approach to sensing technology where there's no chemical reactions. I mean, there are, but they're happening naturally with the biofilm. There's no like catalysts or moving parts or consumables or what do you call them? Aliquots. So none of those things, which is where you know, those are the typical terms and techniques that you use for monitoring or sampling. So this is a bit of a different approach. So anyway, I'll stop talking for a minute and see if anyone does have any questions in the chat or by raising your hand or just coming off mute. And then if not, I'll jump into some of the freshwater work that we're doing.
Oh, I haven't seen anyone with any questions in the chat. So perhaps you can move on to freshwater situation.
Sure. All right. So one of our cases in freshwater monitoring is very much freshwater quality monitoring. So it's in a watershed management capacity. So we have a partner in Orlando, Florida. So they're the Lake Cane Restoration Society. So it's a nonprofit whose goal is to keep their lake swimmable, fishable, and lovable. And they've had some concerns. So they're right beside Universal Orlando. So they've been concerned for many years about the impact of the big parks and the urban development on the quality of the lake. And it's very, very loved and very used as a swimming lake. They've been seeing some eutrophication, which, you know, can lead to algal blooms or a changeover in the natural plant life in the lake. And one of their main concerns is this small stormwater retention basin drains directly into Lake Cane. So Lake Cane is spring fed, so there's no large river source, but it does get fed by this very small retention basin. And they've been concerned about how the residents of that lake are managing their own stormwater runoff into the retention basin and how that's impacting the health of the lake. So what we were able to do is put Sentry sensors near their manual sampling locations. So because they have a volunteer organization who's doing manual sampling, they have an established plan for where they sample. So we were able to put a sensor over here near the influent to Lake Odell, and then in the water a little bit more, about 100 feet offshore, to start to understand the impacts of the general lake health and the influent from Lake Odell specifically. And the findings were very indicative that the Lake Odell influent has quite a significant impact on the lake health as a whole. Now, the sensors are relatively close together, so I'm sure we would see a much smaller impact to the far reaches of the lake. But it was definitely a great stepping stone for them to start having those conversations with the property owners around Lake Odell with sort of some hard data to show that their activities around their lake are having an impact on the larger environment. And then additionally, in a watershed management kind of environment, when you're able to get a baseline of what is the data now, and this is relevant in any facility, what's the baseline now so that you can actually evaluate the impact of any changes you make. And then you can also be flagging poor water quality times or days to reduce any risk or to start to pinpoint the actual causes of some of those poor water quality days. Is it right after a rain event where you have the large kind of overland runoff? Or is it when it's really dry and you're not getting that influx of fresh water? So trying to figure out what's actually contributing to poor or better lake health or water quality can help you encourage the good things and intervene during times when it's not ideal. And then it can also help develop issue-specific interventions instead of trying to deal with a problem broadly that you don't really know where it's coming from. If, you know, for example, knowing that the influent from Lake Odell is causing these issues, well, maybe some of the filtration or the naturalization of the shorelines can be focused in that area to try to mitigate that source of incoming organic loading. And then also, as I was saying, that hard evidence that these actions do have an impact can help promote the policies in the region that really do help the lake health or reduce the amount of impact to the lake by, for example, building too close or septic tanks or whatever else is impacting the lake health as determined by the data. So that's one of our kind of broader freshwater on the source side. We also do have a case where we were doing a similar type of monitoring, but to the influent of a drinking water treatment facility. And so, you know, these same things are true. So essentially identifying when poor water quality coming into the facility is happening so that you can start to tie those events to treatment outcomes, energy costs, how frequently you need to clean the membranes, energy use, all these things that you're trying to get a handle on as a manager or as an operator can start to be tied back to specific influent events. And then as that profile of what happens over a given day, week, month, year, during a specific event, when it rains, when it doesn't rain, being able to pinpoint how does my facility react to those different conditions allows you to better choose your operation infrastructure of like, okay, when this happens, I already know that this is going to impact my biology or my treatment process in these ways. So I can start to act when I know that it's going to rain, rather than after I found out that my water treatment process is not treating as well as I'd like it to. So I hope that that highlights the use in the drinking water side of things, or at least freshwater side of things. Do we have any questions on the drinking or freshwater side?
Well, that's pretty interesting on the freshwater side. In fact, I was just reading on a case today of some testing that had taken place in a particular location on a coastal area. And it was revealing some the water quality issues and some of the actions that need to be taken. But of course, in islands that are along the coastal areas with lots of tourism, the presence of yachts and multiple users, small coastal fishers, and streams that pour into the bays, some of the impact on the water courses that you can have for activities on land. I think I saw something that Tim posted in the chat about septic tank drain fields can also affect lake quality. Were you speaking of lakes? I guess similar would apply for marine type environments on the coastal the sea coast for that.
Sure, absolutely. Right. Fish cleaning stations are a notorious source of
Right.
high strength BOD, and as well as the flotsam that comes from gutting fish. So yes, all kinds of opportunities to look at water quality related to onshore usage of water.
Okay.
The other, well, so I'll open it for a few more questions if you want. And while I wait for anyone to sort of verbalize or type out a question, I'll jump to one more case that I think is a really particularly interesting one in the wastewater side of things, but that highlights a number of advantages of having that both real-time and ongoing data, but also the larger data set for the patterning. So I'll just take a minute to hop backwards in my slides.
While Alex is doing that, we should let you know that our typical offering is a 6-month trial where we send a panel and 2 sensors to our clients. They install them in locations that are appropriate for them to understand their water quality issue, and that 6-month trial provides enough time for us to understand the signal that is being developed by the sensors and to offer suggestions to our clients about causes of that signal change and other things that they may do to their treatment facility to mitigate harmful effects of toxins entering or high strength waste entering the facility.
I have a question.
Yeah,
or a comment. Hi, afternoon, everyone. Joe invited from Trinidad with dealing with the sewage treatment plants that I deal with, or just from comments from other operators. The plants are old, and certain technologies, you'll have to have certain modifications to the plants. Let's just say you have high BODs or high suspended solids or whatever the factor, whatever factor it is that would affect your EMA readings or whichever local body readings or whatever parameter. Would it be sensible to do a pre-assessment or based off our recommendations or certain reports, so that you'll have the technology will work? But if it is that the plant itself or the equipment or the SCP needs modification, would it be sensible enough to install this and then to find out that you need some big modification? Would it be, or would you have like a pre-assessment of a team from Sentry come to a pre-assessment of the facility to say, well, in reality, you really need modifications to your equipment before you install these kind of technology?
Great question. We're starting to do a lot more work with consulting engineers because they recognize that simply creating more capacity in a facility is not necessarily the cost-effective thing to do for that particular client. In those cases, being able to understand to characterize the wastewater concentration, flow, and temperature, for example, is helpful for a design engineer to be able to narrow the improvements or focus the improvements to mitigate the particular wastewater quality characteristics coming into the facility. Great question.
Yeah, but in terms of that initial part, so what we typically do before we install is we have a logistics call, and that's where we iron out the details of, all right, what are you trying to solve? So where would we put it? Where makes the most sense based on your layout at your facility to put the sensors to answer, to get the data that's exactly going to answer what you're looking for. If you're trying to optimize the aeration, you maybe want to have a sensor before the aeration tank and after the aeration tank to really see what a difference is when you change aeration. And so being able to figure that out, and then once we've identified where, then we figure out, okay, does it fit here? Is there somewhere to put it? So we actually have that conversation as part of the pre-installation. We call it the logistics call, so that when we send the sensor and it goes in, we already know all of the things that we need to be aware of before it goes in. So I hope those two parts of it answer your question.
Yeah, that was good because, again, dealing with, old treatment systems, let's just say 20 years old, some are 30 years old, there's a specific capacity and there's no long-term planning as for, let's just say, an increase in personnel in a particular community, or let's just say an industrial plant or oil and gas facility. You have, increase in personnel or decrease, and you have systems that are already concreted. And yet still, they look for parameters, and they test for parameters from the EMA or the local body. And it goes into non-conformance for years after years, and, steps to try to mitigate against it. As you correctly said, they do the grab sampling technique, and it doesn't really show the long term, or it doesn't really give a spread as to what is actually going on in the system. So I thought, let me ask that question because, a lot of times, even as consultants, you might operate as a consultant and we give a particular feedback, and it's like, okay, you need a modification on the system and this kind of stuff. So, but I see the value in this system, and and that's why I asked it for the pre-assessment. So yeah, the questions are really answered.
Great.
Yeah.
One more comment. Every treatment plant seems to have a bottleneck. It is one part of the process or another. And that'll happen sometimes when facilities are added onto over time. You're simply looking at the next bottleneck that is being created or has been created as a result of an improvement. This is the kind of technology that can help you identify those bottlenecks and target improvements to get rid of that bottleneck.
Okay, great. Thanks.
Mm-hmm. All right. Yeah, so I wanted to talk about this case because I think it highlights a lot of the ways that the sensor can be helpful. So it was installed. So basically in Frankfort, Kentucky, there's a wastewater treatment plant, much like in Tim's case in Bend, small facility in a small town with a fairly large industrial discharger, which is a distillery that's very close to the influent of the plant. So there's not a lot of time for that load to start, biodegrading on its own on its way to the treatment facility. So it's pretty fresh. Then you also deal, when you have industrial dischargers like food and beverage, there's also the toxic side of things when they do cleaning, right? So they installed the Sentry in the influent and then in the RAS system to be able to track what's coming in and when, and then how does it progress through the facility. To be able to start to profile, as we were saying, profile what comes in and when, and flag those events. So essentially what we did was we looked at, and this is our process as we install the sensor, because it's a live biology, the level or the absolute values may be a little bit different from facility to facility, depending on what comes in. So as the sensor shows us what the normal range is, we establish alarm bands. And then once the sensor picks up a signal that goes outside of that established alarm, then an email is generated to whoever wants to be on that list. So to the people who need to know these things, and they get that email to basically say, hey, something's going on. And so the sensor was installed to basically identify these distillery events, which it did. It also identified that the plant is particularly susceptible to high rain dilution, which I don't think that they probably suspected, but this really showed that when there were high rain dilution events, the treatment biology was impacted fairly significantly. And then the other finding was very interesting. So as we were able to do the analysis, so as I mentioned, we're getting these huge data sets instead of 1, 2, samples per day. We're able to get a really good idea of what happens and when over time, over a longer period of time. And what we were able to identify is that, like for whatever reason, Wednesdays are really weird. Like, what are you guys doing on Wednesdays? Like, what's that about? And they were like, well, I don't know, maybe it's the distillery, maybe that's what's happening. So they talked to the distillery and found out that it wasn't the distillery causing these unknown spikes and drops and just all kinds of activity on Wednesday. So what they were able to find out was that it was actually the day that the leachate trucks dump into the receiving station on Wednesdays, and it's the day that the maintenance is done on the EQ tank where they clean it. So not only were they getting this huge organic load, but they're also introducing a biocide to kill the biology on the same day. And that was actually what was causing all these problems. So they thought it was the distillery, and the distiller wasn't not impacting the treatment process, but the real finding was that they had a disconnect between some of the collections activities that were going on and some of the facility activities that were going on. And so what they are able to do with that is really start to identify, okay, let's plan those things out better so that we're not causing our own challenges. And then with the heavy rain, be able to make those changes or adjustment into HRT or add additional carbon loading to be able to, save that biology and preserve their biomass for those high loading events. And then being able to reduce aeration when there's lower events and only turn it up as an event is happening instead of always operating as if it's the maximum loading possible. And so this year we're adding a second system in this facility to start to dial in some of those operational changes even more. So this case I find highlights a lot of the things. So not only the toxicity detection and the footprint or the profiling of what comes in and when, but also being able to start to diagnose how do my operational decisions impact my treatment capacity, and are there things that I wasn't suspecting are really influencing my facility, and I've been thinking it's something else and addressing something else. So much like the Lake Kane case with the freshwater monitoring, being able to know what actually impacts your treatment and your water, your effluent quality versus what you think is really, really helpful in being able to choose the right upgrades, if that's what it comes to, or the right operational changes and SOPs to follow to really get that optimal treatment outcome that you're looking for. And I did want to go back to my, sorry, I'm going to hop back through these. I have all my cases in this one, so. I just wanted to mention quickly, so I know that this is, we're talking about this tech solution. We're called Sentry Water Tech. It's innovative, it's new, etc. But one thing I really wanted to highlight was that it is designed to go in wastewater and is designed to be simple to install. So you have these probes that can be installed in all these different ways. They're not finicky. They're not, there's no little tiny bits to connect to other little bits. You can develop your own infrastructure for putting it in. We have guidelines for that. And then the panel itself just needs a plug and cell phone coverage. So it's designed to be kind of a, yes, it's high tech, but it's designed to be a very low barrier to installation system, because we recognize that, like you said, some of these treatment facilities are not new and shiny and super connected. and some of them are. And so being able to get the data while you're still deciding on upgrades, or if you don't have the budget, all the way to when you do start to implement those upgrades, it can transition in during those times too. It looks like Timothy has a question.
Hi, good day. A very interesting system you have there. Just wanted to know what is the unit of measure that the system uses, so that you could, if you have to go to our local authority, the EMA, for the water pollution rules, we'd need to let them know that. I know it measures it more or less measures the or tells you the activity of the microorganisms, right? But what is the unit using? Is it milliamps, volts? That kind
I'll
of
let
thing.
Tim I'll let Tim take this one.
Yeah,
I can do my own take, but I think Tim will hit it on the head.
The signal is microamps. We're actually measuring the amount of electrons moving from anode to cathode through the circuit. This is unlike most other measures of organic matter, what we refer to as OMOM. Those other measures of organic matter are all concentration based. This is a rate based measure. We have been able to get good correlation between our measure, which we call carbon consumption rate, and those other measures of organic matter like BOD or COD, TOC, volatile fatty acids. So it's a different kind of measure, but it is widely applicable and comparable to those other measures that are more familiar to operations personnel.
Great, thank you very much, sir.
You bet.
I'm trying to think if I have a good slide in here to showcase that, some of those relationships.
No.
Does anyone else have other questions about how the sensor is working, or what other applications we've been exploring with it? Again, if you have a specific challenge, now that the different cases are percolating around, if you have a specific challenge that you're trying to address, feel free to ask around about how it might be deployed in your case at your facility.
Hello, has everybody disappeared?
I should let you know that a major focus, my major focus over the last 6 months has been improving the ways in which the sensors are installed to try and avoid problems associated with the wastewater environment. For example, we know that installing a sensor downstream of a screening device is much better than upstream, just because you're taking rags and other trash out of the waste stream before it reaches the sensor. We're also looking at ways in which the sensor can be mounted in channels and tanks to minimize the catching of any rags or stringy material that may get through a bar screen or other screening device. So the actual installation depends very much on the tank in which it's going to be located and the problem statement that the client is looking to achieve through active monitoring of their waste stream.
There we go. Put my installation slide back up. All right. Well, Ignatius, I guess so. We've come to the hour, so I'm happy to stay on longer if people do have questions.
Well, I'll invite any questions if the other colleagues on the chat do have any. I haven't seen any in the chat room, but I think it was a good expose in understanding some of options that are available for utilities and other interested parties for monitoring water quality in these parts. As we, and I think we had some pretty good interventions out of Trinidad, I think, where we have a lot more central sewage systems. So that was pretty good. Valerie, you have any closing comments?
No, this is more that your technical guys,
Right.
applications that they'd see in their own utilities.
Yeah, but it's always good that they can get that type of exposure, knowing some of the technologies that exist, even where they are not in place at this stage.
Yeah.
So
Well,
I'd like to, yes, I'd like to thank on behalf of the team, to thank Valerie for reaching out to you, and to thank you, Alex and Tim, for this very wonderful presentation, very educational. And of course, it's being recorded, so we're going to circulate it to the participants, and it's always there for use for others who probably registered and missed it for one reason or another. So I'd like to thank you very much for this, and we hope that we can continue to connect with you in the future.
We do too. Thank you very much, everyone, for attending.
Thank you. Yes.
Thank you very much. I'm Ignatius Jean from.
Before everybody goes off, Ignatius, before you head out today, if you have a subject that you would like to see, on our Wednesday webinars, put it in the chat, because Ignatius and I, go looking for speakers. It's challenging, obviously, because we do this every week, not every 2 months, as many people do. So we'd like to really meet your needs. And if you have a subject that's near and dear to your heart, let us know, and we'll try and find a speaker on that topic. So just take a moment in the chat before you head out today and just say, is this something you can address? And we'll have a look at it for you. Thanks, Ignatius.
Right. So thank you very much, everyone. I'm Ignatius Jean.
Thank you very much.
Signing off from CAWASA Wednesday webinar number 7. And we hope that we can see you again soon.
Bye now.
Bye.
Thanks all.
Thank you. Bye.
Thank you, everyone.